Okay, so with that, we're done with the alcohol reactions already. Okay, so I trust down a blank piece of paper. We will now link up all the different functions together. I remember I've done it last year. I didn't, is it? When we link the different functions together, have we done it before? I asked the Saturday class people, they say no lah. Therefore, you all have done it before? No. Okay, you need to have a different a few colors. Okay, so on the page right, maybe middle or anywhere, we randomly write down alkanes. I leave it to you. If you prefer to draw the structure for alkane, you do it. Okay, if not, you do the same. All right. Then I use a more loud color to write down the acronym strategy. Right. For alkanes, just remember the number 1, because there's only one important reaction that we have, which is pre-rep sub. After undergoing pre-rep sub, right, then what function group does it generate? Okay, what does RS represent? Filipino alkane, the previous chapter. Okay. Okay. So from here to here, and write down free radical sub. Okay. My purpose is not to, for you to write down the full reagent condition. My purpose for this one is just to link, the connector, how to convert from one function to another one. That's what always Cambridge tells you, and we always blur. So after you go home, you want to add on the full reagent condition, you can go okay. All right, okay? Okay, then done. Right. Now let's focus on RX, right? We do have a certain strategies, right? So Clayton, can you help me out here? What strategy do we bring in so we call the reactions of halogen alkanes? Is it some acronyms, or is it, I don't know. What is it? What do we bring in for halogen alkanes? Do you bring anything at all? Do I bring anything at all? No, huh? Yes or no? You look at me and smile. Means I think you did write it in, but I forgot. Is it? Lashita? Hot 4 times. These halogenal alkanes, the previous function group. So you say? She just have a CCA because every Monday is CCA, so she's a big stan. My question is, what is the strategy we bring in to record the reactions of halogenal alkanes? You got that today? Huh? Association, right? So what do we start off with? Braden, back to you. She already helped you already. Association. So what do we recall first? What is the most common bench reagent you have in the lab? Have you been to the lab in January? Not yet, right? But last year you've been to the lab, right? So what's the most common one you have available on the bench? I mean, there's a lot, but one of them cannot totally no recollection lah. John? Jonathan? Yeah, correct. No, your dilute sodium hydroxide. Then after that, you link it to still you until you tell me one correct answer. You know everything you lah. Then the rest is happy. Quick. You link it to associate to. Huh? Hey, hello. Sodium hydroxide in. Very good. Alcohol medium, right? Then you link it to another one also in alcohol medium, but a different reagent, right? Which is NaCN. Finally, the N you associate to. Very good. Or amines. Okay, can.
Then there's the excess.
That one?
Limited thing.
Yeah, that one is the detailed condition. That one I'm not going to focus here. Yeah, here we're going to just focus on, how to link one function group to another one, okay? Okay, when you react with NaOH, what function does it give you, Creighton? When you react with this, what function does it give you, Craig? What function does it give you? Is it?
Alcohol.
Okay, very good. Alcohol, which is what we learned today, right? Alcohol. Okay, like what mentions the full reaction condition, I'm not going to focus, right? When we react with this, okay, John, what function does it give you? We don't refer, don't look down here. Very good, alkene, okay. Or you want to present using the C, this one also can after you, okay? When you react with NaCN, so now what function does it give you? Hmm? I know, so I taught you, okay? R, C, triple bond, N, your nitrile group, right? Okay, last one. When we react with ammonium amine, what function does it give you? If you have a better way of, not so messy, you just go, okay, yeah. So it give you amine. Okay, now let's move on. Okay, let's do alkene, right? Can I have the acronym for alkene, John? Or whatever strategy we brought in, and you have to have top 4 times. So we have the H, 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 O, and P, right? Okay. Can you tell me can you tell me everything? What does the first H represent? In no particular order, just tell me the H. I told you already, content very easy to absorb, right? You want to throw out content a bit tough, right? First H is, for example, H2. This one I have to memorize because I cannot use logic to deduce, right? No way, right? If I can use logic, I will confirm tell you one. Okay, H2. Then HX. Then halogen, basically X2, right? Next H is steam, oxidation. This one not in syllabus, polymerization. I just put the P there to link up to this thing called hot photons, H4OP, right? Okay. When you react with H2, what does it give you? Graydon. You want me to stop calling your name, right? You very good. Finally, you break the curse. Later on, I'll ask someone else already. Okay, so this is your back to your alkane, right? Why not? Alkene plus H2. Can. Okay, like what I mentioned, I'm very messy here, right? If you have a way to do it, or maybe next time you go home and do an iPad, I think iPad is easier for you to arrange, right? You can do that. Okay, because my job is not to make it neat. My job is to just show you how to link up using all the strategy that I shared with you. Okay, then? Okay, when you react with this one here, which is the HX or halogen, it gives you the same functional group. The only difference is that whether you incorporate one halogen or two halogens, that's all. What functional does it give you? This one, right? So this one here, I can go, I don't know how to link it. It's basically this one. Basically this one. Okay, where you react with your HX or halogen. So basically it's either HX or X2. Okay, like what I mentioned, you go and make it neat now. Steam is just above only this way. Okay, where you react with your steam. Right, H2O gas. Okay, oxidation you can choose not to link up because it can give you different products here, so I can don't link. Okay, let's move on to RCN. Okay, John, give me one linkage where I can join nitrile or something else. Craig, give me another linkage. This one got two reactions, but okay, very good. Amy, from here I can go down. This reaction is called reduction. Okay, Now there's another reaction that C triple bond N undergo, which is very good. And give us, RCOOH, assuming it's acid hydrolysis, right? So from here it go down here. This is hydrolysis. Okay. Okay. Now then we are left with this one, right? Okay, ROH. What was the acronym then? We just learned right. Oh, what was the acronym? You don't scare me there. I saw you so focused and copied out, so I know you are listening, right? Yeah, China, CHE, China, and OI. Okay. Combustion on good linkage because it gives you CO2 and water, so we don't need to link. Okay, this one we need to do halogenation. All right. After alcohol undergo halogenation, what does it give you? Song Yeon, you want to help me out here? Very good. So from here, all right, this is the anhydrous PCl5, right? Okay, right? Okay, John, the first E is in no particular sequence. I'm going to show you the application, you do extra, right? Okay, so that one I think we don't need to do anything. So probably for the estimation, I don't do. I will do the second E. What do you think is the second E? Okay, I will give you here, just nice. I'm sorry, here, go down. So you minus, watch it, this is elimination, right? Here. Right? Remember, you don't copy holes here because mine is messy. Right? Yeah, I remember you always go to make it one. Okay, next one. Na is also not a good linkage in terms of the product it gives you is not of organic nature, right? So sort directly, so I probably will not do the linkage. O, I will do it. I will do. O is the oxidation, right? Okay. So when you have an oxidation, what does it give you? It's going to give you a new function group by no space already. It's going to give you either this thing called carbonyl compound, which is either aldehyde or ketone. Oxidation. So from here, oxidation from here all the way to here. That is oxidation. Okay. So if you make it neat, right? Okay, then it becomes that easy because on Saturday class we actually did the synthesis of the halogen alkene, the question itself, right? And then actually when you have this one, when you are familiar with this one, it's very easy for you to come up with a syntactic route. So step 1 do what, step 2 do things like that. Okay, so keep this with you because we will be using it because you realize that we still have carbonyl compound that we haven't linked it up yet. It comes with the own strategy, own acronym. A means we also have certain strategy here. Carbon dioxide come out already, but we haven't shared with you the acronym yet. So these are the few that we still have to link up. But actually your content is almost there. We only left what? 1, 2, 3. That's all. Right? Almost already. So if you ask me, Justin, is it time for me to revise? I think yes, right? Yeah. Okay, ma? Can? Okay, as promised, 5 minutes. We resume at around 55. Okay, we start with MCQ first now, okay? Don't tell me I never record. No, I'll cry you, right? Okay, question 1. Can I start with Jonathan first? Your answer, please. Wrong level, my answer, not my answer. C. Anyone C? C? What answer? B? No answer. Very good, both of you. It is B. Let's do it together. Do you draw it out or you use eye power to I power. Maybe this one you can draw this out, okay? Now I think we did something similar before that time is to remove the HS. The but now is now remove water, right? Which isomer, when undergo dehydration, meaning removal of H2O bonded to adjacent carbon, right? Give the largest number of different alkenes. So different alkenes probably is talking about the different isomer, like maybe cis trans or different constitutional isomer, things like that. Okay. You choose C, right? C, if you draw this out, right? H. Okay. Okay. There is only one way for you to remove the H and OH because whether you remove here or remove here, right, it will give you the same alkene. Your double bond will always be between the second and the third carbon, right? When you remove the one I box up, all right, and you count from the left side, it's still between second and third carbon, right? Correct now. But if you remove the water that I circle itself, right, the alkene, the double bond, right, will still be on second and the third carbon when you count from the right side. Right not? Yeah, so therefore for C itself, right, the total number of alkene we have is 2. Why only 2? Because of cis and trans. Cis and trans. Okay? Right. Now, why is it B if you draw this out? Okay, there is a difference depending on where you remove the water itself. If I remove the H or OH that I box up, okay, my double bond will be between the second and the third carbon, right? But if I remove at the terminal end here, then my double bond between the first and the second one, right? So this one here will result in cis and trans. This one will not because the one of the carbon here is bonded to 2 exactly identical H itself, so it don't fulfill the requirement for cis and trans. So total number of alkene product you have is 1, 2, and then 3. So B is 3 product here. C only have 2, so C win. Is it okay? Since you all didn't choose A and D, so I don't need to go through. John Kenner. So I think your issue is just use eye power. Okay, question 2. Graydon, your answer? You choose B. Okay. John? B. B. It's okay, Pam. D. My answer is different, all different from yours. Okay. Now, what is the faster way? Let me underline this one first. Basically, the question asks you to find out, determine how many isomers that will give you positive reactions with alkaline equals aldene, right? So I mentioned before, this one, alkaline equals aldene, basically is your idle form test. Can you come into the annotation first? You have to first recognize that this reagent conditions here referring to this particular test called idle form test, right? Okay, to give you a positive observations, right? There's one criteria, right? What is the only criteria? Very good. We must have this thing called methyl alcohol. So we start by drawing the structural features, featuring this methyl alcohol, which means I need to have CH3 here, bonded to a C, H here, at the bottom OH. I need to have this structural feature here. So I will draw this first. Okay? Next one, let's take a look at the molecular formula. Total number of carbon is only 5, which means that this portion here, I already used 2 carbon, right? So this portion here, I only have 3 carbon to play around with to come up with different arrangement. Am I right to say that? So I draw 1, 2, 3. So the remaining 3 carbon can be just in a linear fashion, like that. Am I right? Or we pick another one. Okay. Instead of drawing the 3 carbon, in a linear fashion, I can arrange it such that I only have 2 here, and one of the third CH3, I put it on this particular carbon to create a branch. So how many different isomers do we have that will give you positive result with other firm has only two. So you see how I do, right? I start by drawing this one here. Then I play around with the black portion. Is it okay? So answer is C. Okay, write down the thought process. Okay, remember MCQ is not just about getting it right. So it must be within the 2 minutes. So must do it fast. Okay? Okay? Sure. Because if I give you 2 hours for MCQ, you sure probably can come up with the answer one. But the problem with MCQ, whether it's O level, A level, is always about the time. Okay? Okay, let's move on. Question 3. Can we have Lashita? You tell me the answer.
B.
B. Okay. Your answer, Clayton? A. John? D. C. A, B, C. Okay, answer, congratulations. You are right. Answer is A. Let's go through this. Okay. You are not by luck, right? Because you already got 2 correct already. Huh? You by feel, is it? Then you have a very good sensing, Okay, which process give at least one product that is a gas at room temperature and pressure? When you dehydrate alcohol, may I know what's a product? You help me, you're the one who choose A, right? So when you when you have your ethanol, right? When you're undergoing eliminations, what product do you get? You buy fuel one, is it? You got an alkene, right? So this is a ethene. From O level, we know this is a gas, right? Okay, let's move on to figure out what is why not. Why not is okay. Classification of this, when you merge these two, okay, ethanol is liquid state from O levels. Ethanol acid is a vinegar liquid state. You merge two things together, it cannot be gas already. It have to be liquid state also. So your ester is liquid state. Your byproduct water, of course, is liquid state. Right.
Wait, I thought ester is like gas because it's sweet smelling.
Sweet smelling liquid. Sweet smelling liquid. Okay. Yeah. Which maybe probably can vaporize easily, but it definitely is not as a gas. It's not a gas at first. Okay. Oxidations of ethanol by hot acidified potassium dichromate. Okay. So in this case here, it will give you your ethanol. CH3C double bond OH. So this is one of the aldehyde, all right? Your ethanol is already liquid state. Upon oxidation, I don't think the MR changed much, right? Okay, probably this one will also be liquid state as well, okay? Now, D, substitution of this by hydrogen bromide, okay? So what you have is CH3CH2 Br. This one here is already liquid. Most likely this one will be liquid as well because the electron cluster is pretty big size because of Br. So it should be quite substantial in terms of body point. Okay? Right. Yeah, so A. Okay. So you can see this kind of question need you to recall content learned from Cambodia. Question 4. Song Yong, your answer? D. Okay, your answer, Craydon? C. Answer is D. Okay, now remember CH3COCl, the name is called, in general, acyl chloride. Okay, go back to check here. Remember the Z strategy, acyl chloride is here. It can form ester by reacting with alcohol or react with phenol, right? So in this case here, you draw this out. CH2, there's an OH here. And after that, you have CHOH 4 times. Then C double bond OH. This is an aldehyde. This is not alcohol. So the total number of alcohol we have is 1 plus 4, total 5. So I have 5 OH group that's possible to react with this acyl chloride to give you an acid. Okay, Ken? Okay. Can you help me draw this up? So therefore, anyway, since we are here, right, whenever you see the condensed formula CHO, it represents aldehyde. CHO means aldehyde. I'll bring this in again when I go to carbonyl compound, which is the next chapter after alcohol. Okay, Ken? Right, can we move on? Yeah. Okay, question 5, skip. Question 6. Can I have an answer, Freedom? Haven't do. Okay, your answer? You guess A lah. C, put C. Okay, Lashita? D, then you? Okay, remember this one? This one here. Next time when you all see this, you know this UV. So this is free rad sub, right? So we learned that free radical sub is always give you low yield because it can produce more than one mono subunit product. So whenever you see this, we go straight to B. Don't even need to figure out the rest already. Okay, Ken? We don't really need to figure out. Okay, we still have time. Let's continue. 7, 8, 2 questions only. 7 and 8. Free rad sub always give you low yield, right? Remember, because of the fact that we always produce more than one mono, yes, yeah. Okay, so the moment you see free rad sub, no need to think, circle. Okay, okay, 7 and 8, 5 minutes, 2 minutes each. Okay, start now. I'll go through when it's heat, 9:25. Then I'll run through before I call your date. Wait, I will check. Am I recorded? Okay, recording already. Okay, 7 answer is Lashita. Okay, so then you say first. The evaporations of ethene ethanol is this. So I want to produce double bond from alcohol, right? Isn't this elimination, right? So it's either B or C, right? Then why is there a need for us to add solution Z to purify? Purify what? Usually the corn H2SO4, we always added in excess to ensure complete reactions, isn't it? All right. So therefore, at the end, right, beside your ethene is mixed with your unreacted corn H2SO4. So that's why we need to add solution Z to neutralize it, right? The answer is C. Make sense? Okay. Okay. And
why is it not the C and
why is it not this one, is it?
yeah?
This is to eliminate the previous chapter on halogenol alkane, right? The HX atom, isn't it? Now this is an alcohol, right? Okay, can I? Okay, this one here. Okay, this one I say that we cannot use I power, right? Okay, they say they does not contain any CC double bond. So of course, if you try out to draw 6 OH, right, you realize there's not enough H to go around, like what Lashita had actually, test out. So 1, 2, 3, 4, 5. The last one should be an aldehyde, because that's the only way I can actually create a double bond without introducing alkene. Whenever we create double bond, right, the hydrogen number can be lesser than expected. Okay, then the rest will just be alcohol and hydrogen atoms. Okay, so how many sodium will react? Okay, basically 5. How many H2? 5 divided by 2, so 2.5. So answer is A. Got it? Okay. Yeah, I think we'll pause here for last. Please complete the only 4 MCQ. 12, 15, 16, 17. Basically, you just need to use 8 minutes to do. So please do. Don't come here and say, hey, I'll do now. Okay? 10. Okay, so next lessons, I will wrap up the entire thing, including structured questions and the next page. Before we move on to acid bases, I will see how your school sequence is. Okay, if your school not touching acid bases, probably I will continue with more organic to come. All right. What's that for? So you want organic or don't want?
I don't know.
Okay. Huh? Sure, go ahead.